Welcome to part 2 of the video of linear regression, where we're going to go over residuals. So a residual is the difference between an observed value and the predicted value by the regression line, which is the vertical distance between a point and the line of best fit. Now the observed value is what we called the actual value in the previous video. So the difference between the actual y value and the y value that you would get from the line of best fit, that is called your residual. So if the point is above the line of best fit, you have a positive residual. And if the point is below the line of best fit, you have a negative residual. Sorry, that is an L there. So what you do is you take the observed or the actual value of y and you subtract the predicted y value. Examining residuals can be useful in determining how well a regression line fits the data. Points above the line of best fit have a positive residual and points below have a negative residual. A residual plot is a scatter plot of the residuals with the line of best fit being the horizontal axis. So if this is your line of best fit, comparing your unit 1 mark to your final mark, what the residual does is it has the same x-axis, so the x-axis is the unit 1 mark, and the y-axis is the residual. So basically, this point here, if we calculated the residual, that is where that point is. So it's about 8. You can see here, the residual is about 8. So that means the difference between that point and the line is about 8. So all you're really doing is taking the line of best fit, making it horizontal, and then we're looking at the difference between the point and the line. So this point is here, this point is here, this point is here, this point is here, etc. A residual plot helps us assess the fit of a linear regression line. If its pattern in the plot is an unstructured horizontal band centered at 0, which is the center of the residuals, then the regression line fits the data well. If its pattern has a curve, then the relationship is nonlinear rather than linear. Therefore, a straight line is not a good description of such relationship. That means if this just looks like a scattering of points, some above, some below, then a line of best fit was the best to use. If you notice that these points kind of curved, then it would tell you that you would have been better using a curve of best fit. So what we're going to do is to calculate the actual residuals. All right, so this was the equation of our line of best fit here. But the one that we calculated before with more detail was y equals 0.7762 x plus 17.0536. The equation here that Fathom gives you from here to here, the final mark is your y value. There is your a value. Unit 1 mark is your x value, plus the 17 is your b value. Now, they round quite significantly, so we're going to use this equation that we got using the formula. Now, what we're going to do is we're actually going to change this because this wasn't first year averages. This is going to be your predicted final mark. So your predicted final mark. So person number 1's unit 1 mark was 81. If they used the line of best fit, it would have been 0.7762 times x, which is 81, plus 17.0536. So if they used the line of best fit, they would have found that this person's final mark should have been 80. So that would have been the predicted y value. But the person's actual y value was 85. So the residual is the actual mark minus the predicted mark. So the residual is 5. Once again, if a person got 46 and we used the equation of the line of best fit and substituted 46 in for x, they would have got 53 by using the line of best fit. So it was predicted that they would get 53, but they actually got 60. So the residual is equal to 7. If we continued this person's predicted mark would be 71. This person's predicted mark would be 60. This one would be 78. This one would also be 78. This one would be 81. And then 50, 93, 91, 67, and 58. And then the residuals would have been 2, negative 11, negative 7, 6, negative 4, 8, 1, 5, negative 14, and 1. So that's how you determine the residuals. So you use the line of best fit to determine the predicted y value, and you subtract those from the actual y values. Now, in order to figure out which points are outliers, what you have to do is calculate the standard deviation of the residuals. What you would do is you would take all of these residuals and you would put them into fathom, and then you would find that the standard deviation was 7.3. Now an outlier is going to be any residual which is greater than or equal to 2 times the standard deviation of the residuals, or is less than or equal to negative 2 times the standard deviation of the residuals. So 2 times the standard deviation is 14.3. Negative 2 times the standard deviation is negative 14.3. So any residual bigger than that or smaller than that is an outlier. So do we have any residuals that are bigger than 14.3 or less than negative 14.3? Doesn't look like it. We got one close, but it's not bigger than 14.3, so there are no outliers. Later on, you'll be doing a computer activity which will show you how to do this calculation using Fathom. So you might get a question that asks you, what is the range of residuals? So our residuals, the lowest value of residuals was -14, and the highest residual was 8. So I want you to once again write down what your Unit 1 test mark was. So let's say it was 70. And then from using the line of best fit, what I want you to do is to write down what your predicted mark was, 71, or whatever your predicted mark was. So if I had a 70, my predicted mark would be 71. So this model is telling me that if I got a 70 on my Unit 1 test, it's predicted that I would get a 71 on my final mark. So it's saying, according to the residuals, how far off the predicted value might your actual final mark be? Well, our residuals go down 14, so the lowest it could be, according to this model, is 57. And our highest residual is 8, so if we add 8, that gives us 79. So according to this sample and model, which is the line of best fit, my mark will be between 57 to 79%. So how big that range is helps to tell you how accurate this prediction is in finding your mark. 57 to 79 is a 22% mark difference. So that's quite a big range. So it gives you an idea of how accurate you think that this line of best fit is. So make sure what you've done here is you've put your predicted mark here and your predicted final mark here, and then subtracted 14 and added 8, and you get your range. So this here is called the range of residual, or residual range. And make sure that you know how to do this, because there will be a question like that on the task. So if there was anything you didn't understand here, please ask your teacher, make note of it, ask your teacher, and she or he will answer that question in class. Thanks. Bye-bye.